Hello guys, we continue with our analysis of applications of functions, in particular the quadratic function. So let's look at this problem, this second problem. Uh, we have the following. We know that f is a quadratic function. We also know that its vertex is the point 1, 4, and its y-intercept is 6. So let's find the equation that defines the function f. And what do I mean by that? What do I mean by this statement? Well, we know that since f is a quadratic equation, it must have this general function, right? A times x squared plus bx plus c. We know this. So basically what we need to know, what we need to find in order to satisfy this statement or in order to resolve this problem is these three coefficients. We need to find A, B, and C. Once we find them, we can say that we have solved the problem. Perfect. So how do we go about it? What do we do? Okay, this is sort of like a detective work, guys, in the sense that you have to gather as many information as you know. And in particular, this problem is solved in this way. You're going to use, obviously, the information that I'm giving you, the vertex, this point, the y-intercept, all these things you're going to use. I mean, they're given for a reason, right? Okay, so let's see. How do I use the vertex in my problem? What I can do is the following. I know that the vertex has coordinates vx and vy. And I know now that the coordinate vx is given by the formula minus b over 2a, where b and a are the coefficients of my function. And I know that the coefficient y of the vertex is the function evaluated in such number, minus v over 2a. Okay, so basically, if I'm giving the vertex, which is 1, 4, what I can do is the following. I can do the following. Look, what is Vx? Is the first coordinate of the vertex, okay, which is 1. So I can write this. Minus b over 2a is going to be equal to 1. According to this, that's what I can do. So that's the first thing I know. And I'm gonna, since this is an equation, it's a good idea to label it. Let's call this equation 1. Okay. Now, the y-coordinate of the vertex, which is this one, is given by this f of minus b over 2a. But what is minus b over 2a? Is 1. So basically, if I evaluate the function in 1, which is minus b over 2a, well, let me say it in another way because I don't want to confuse you. Vy, how much is Vy? Vy is 4. So I'm gonna first start to do that. So Vy is equal to this, and since Vy is equal to 4, I can write 4 equals the function evaluated in minus b over 2a. You see, I'm gonna do it very slowly. Next, I can say that 4 equals the function evaluated in this number, which is 1 according to my first equation. So 4 is equal to f evaluated in 1. And my function is this, right? My function has this shape. So f of 1, when I introduce f of 1 in here, it's going to look like so. F of 1 is going to be a times 1 to the square plus b times 1 plus c. Does that make sense? If f of x is equal to all of this, then f of 1 will be equal to all of this with the substitution of 1 in there, in those places. Okay, and if you can see, we have another equation. If we clean it up a little bit, we have 4 equals a plus b plus c. We have another equation, equation 2. Let's label it equation 2. So we have one equation, another equation, and let's see if we can find another equation that relates my coefficients a, b, and c. If you notice, the fact that we haven't used is that the y-intercept is 6. What does that mean? Let's actually draw very quickly these ideas. If I drew the graph of the parabola, it's going to look more or less like this. I know where the vertex is 1,4, which should be about 3, 4, 5, 6. 1,4 should be about here, okay? This is the vertex. And the y-intercept is 6, which is this point over here. So clearly this parabola opens up upwards, right? It goes like this, right? It cannot go downwards because if it went downwards, it wouldn't cross the y-axis at this precise point. So it's got to go upwards, concave upwards. Okay, so basically what I'm saying by doing this little drawing, this little graph, is that this point, that point, which is the y-intercept, which is 0, 6, right? It's a point that those are the coordinates. This point belongs to the function to this function, right? In other words, when I evaluate the function in 0, in this number, what do I get as output? I get 6. You see? So basically, what this information is giving me, this information is telling me, is that when I evaluate f in 0, I'm going to get 6. You see? And how much is f of 0? F of 0 is a times 0 to the square plus b times 0 plus c. So let's actually write that. Equals 6. And if I clean it a little bit more, I get z equals 6, right? Because all of these and these are going to disappear. So if you notice, guys, we have found already one of my coefficients. We have already found c. C is going to be equal to 6. Okay, fine. And I mean, we may call this equation 3 because it's an equation, right? C equals 6. That's an equation. It classifies as an equation. So we have one equation, two equations, three equations that relate three coefficients, A, B, and C. We already have one down. C equals 6. So the rest is just putting this value 6 in here. I'm gonna now, I don't need this anymore. So let's get rid of this. And basically what I'm gonna do next is a system of two equations with two variables. I solve it and I'm done. What equations am I talking about? This one, minus b over 2a equals 1. Minus b over 2a equals 1. And 4 equals a plus b plus c. But how much is c? C is equal to 6. So basically a plus b plus 6. I have two equations with two variables. If we simplify this one a little bit, we get minus b equals 2a. And if we simplify this one, we are going to get a plus b, well, minus 2 equals a plus b. Okay, this is the same as this. They are equivalent. And this is equivalent to this. And now what can we do? Let's for example, let's isolate b from this equation, and I'm gonna get that b equals minus 2 minus a, and now I'm gonna input this b, which is this, in here, okay, right there. So I'm gonna get minus 2 minus a equals 2a, and I end up with an equation with just one variable. Remember, it's not good to work leftwards from left to right, but I'm just doing it due to my constraints, okay? This is not a good idea. You always work in mathematics, you work from upside down. That's the best way. So we are here. So we get minus times minus, it's going to be 2. Minus times minus, we're going to get a equals to a. So this means that a equals 2, right? Very simple. So we have found a. We know c, we know a, and finally, let's put it back here. I can put a now in any place, okay? I can put it right there to get b. I can put it here to get b. I can put it anywhere. Let's put it right there. So 2 times 2 is going to be 4, which means that b is minus 4, right? So I'm just going to conclude that way. B is going to be equals to minus 4. Okay? And we're done. We have completed the full function. F of x will be a, which is 2x squared, and then b, which is minus 4x, and then c, which is 6. We're done. This is my function. This is the function which has a vertex in, what did we say? 1, 4, and that goes through the intercept 0, 6. 2x squared minus 4x plus 6. And we did every single thing in an analytical way. Let's confirm. We have this function. Write it down, please, somewhere. I already have it on Desmos. And there it is. You see? 2x squared minus 4x plus 6 is this parabola, which has its vertex in 1, 4 and goes through the y-intercept 0, 6. Remember that we usually talk of the intercepts by just one number. If I say that the y-intercept is 6, that means that, more properly speaking, the point is 0, 6. If I say that our next intercept is minus 4, what I mean is that this point, the x-intercept is minus 4, 0. Okay, never forget that. They are usually interchangeable, okay, because there is no chance of ambiguity. So that is the first problem, guys.